Hello there. My name is Alan, and this is the introduction and explanation, I suppose, of the tutorial series that I'm building. Hopefully it'll be complete by the time you get to it. And I've actually gone through trying to make a proper introduction video several times now, and I'm not really exactly happy with what I've got so far. The last time through, I spent a lot of time here on this page. If you don't know this individual already, Bucky Roberts is pretty much a kind of tutorial superstar on YouTube, and he has a C++ programming tutorial. And the last time through this introduction, I spent quite a bit of time explaining why this whole approach is wrong. Well, maybe wrong's not the right word, but is not effective, and wouldn't be effective no matter how you look at it. Now, I have nothing against Bucky here. One of the first things I pointed out, and I tried to point out by allowing you to hear the audio, was this initial hook here. Let's see if it'll work. The last time I did this, I had my microphone set to have echo cancellation on, and so no matter how loud I put my speakers, you still couldn't hear it. But now that's off, so you should be able to hear.
And welcome to your very first C++ tutorial. Now, my guess is that if you're watching this video, you probably already have a basic understanding of what C++ is.
Hopefully you can hear it now.
For those of you guys who don't, C++ is a computer programming language. It's how you make computer programs, computer games. So if you're interested in making any of those.
Okay, so now that was the hook part that I was kind of ragging on him about. What can I say? The guy's trying to make a buck, and people like to make computer games, and it's all a big fake. So, like anything else, TV commercial or whatever, I can't blame Bucky any more than I can blame Colgate for telling me their toothpaste is going to make my teeth whiter. But this definitely will not teach you very much about C++. And there are definite reasons why that's true, which I'd like to get into, at least partly in this intro. My approach, the approach that I'm taking at this point, and I believe is the correct approach, actually doesn't begin with C++ at all. In a way, the series I have set up so far is kind of a walk through time. I've finally gone to 2 pages. It starts off essentially here at number 4, where we begin to examine the way things were around the mid-80s. So you went to your store and you went to pick up your brand new IBM compatible PC compatible computer. You brought it home, and you saw this. I'll put the mute on so you don't have to listen. There we go. Yeah, so this is the interface, essentially, that you got when you got your brand new computer at home. Except for this bar here, I can't get rid of for some reason. Go away. Go away. Don't go away. I'd like it to go away. It's just because it's more authentic somehow. Anyway, it's not important. The point is, that was essentially what you got. And of course you had programs that you could buy, and you had the opportunity to make your own programs. And I promptly went out to the store and I bought a Fortran compiler because I learned how to program in Fortran when I was in university. And I wrote a few little things, I think, to make fractals, because I learned a bit about fractals. But there wasn't really much that I can do with the machine. And then a friend of mine came along and showed me this program called debug, which allows you to actually go inside and look at the hardware and the architecture of the computer itself. And that is actually where we're going to be starting. Notice the name of this part 4 here is Intro to Debug. And not to debugging, but debug the program. Debug, which has shipped with every version of DOS ever since the beginning. And you have it on your system if you're running Windows. And what that allows us to do is look at the way things were back in 1985. And by the way, I actually looked this up. I'm going to double check. C++ first draft. $1985. Saw it right there. The first official draft of C++ was released in, I think, according to that blurb there, 1985. What we got from blah blah blah. The labs. It was renamed in '83 as a pun. I didn't know that. Okay, so we're talking about the same time period that C++ was actually being developed. And as we go through the first few lessons and looking at this processor and examining how it works and how DOS works, parts of it, not everything, we're going to run into certain problems and their solutions as well. Some of them, I guess you wouldn't call problems, but ways that DOS tackled certain issues to do with organizing information, with the new disks that were coming out, and managing memory, and various other competitors and bits of software on the market. The ways that the people that designed DOS handled some of these problems has a kind of a general method behind it. That is, the same sorts of solutions appear to be happening or being applied to a wide range of problems. And then there's C++. The people that were designing C++ were interested not in necessarily designing another Fortran or a better Fortran, or even a better C. They were interested in the problem of solving problems in a general way. That is, what commonalities are there that exist between one problem and another? There appeared to be certain, the solutions that people came up with all appeared to have certain common elements. And what they were interested in producing, the people that designed C++, was finding a way, hoping they can find a way to create a framework, a syntax, or a language wherein the structure, the structure of the language makes it easy for one to design solutions for problems in what appeared to be the normal fashion. I'm trying to use simple words so that you don't know, because you don't know the words yet that they eventually invented and are very loosely explained in any of these tutorials. Things like abstraction and virtuals and all that sort of, all those buzzwords came out of the development of C++. So C++, in a sense, is all about its syntax. It's about being able to the problem in C++ is the problem of solving problems. Put it that way, if you like. And so what I'm attempting to do is provide the motivation for the development of the language through this little historical journey. And then, at some point, I believe, and I'm hoping, we're going to run into the same point in history that they ran into, where the only logical step would be to create either something very similar to or almost exactly to the C++ syntax. And so that's the goal, to first motivate it, and then we know why it was developed, what it's for, what problems it was meant to solve, when it's useful, when it should be used, shouldn't be used, and all that sort of stuff. And then we'll switch over to talking about the actual implementation of C++ as it stands today, which is not the way it was in 1983 or whatever. There are many additions that were added on, and it's much cleaner now, and things improve as people discover better ways to do things. As far as the student or the audience, should there ever be one for this tutorial set, what you will need to know, all I would expect from you, even though I'm describing this as an intermediate, possibly advanced level course, is basic understanding of C. So that means, notepad up here, say, basic C. So that means loops, any kind. Fundamental data types. Int, char, float, double, whatever else there is, etc. Signed and unsigned. Simple data structure. That is, if what I type down right now is intelligible to you, then you know. If this is a mystery to you, you don't know. If this makes perfect sense to you, you do know. Now, you might have seen, and a lot of times you notice in C code that they usually write this. Instead. Now, you may or may not know the difference between this statement and the last statement is, and they amount in fact to the same thing. But typically in C you would do it this way. In C++ you'll just omit the typedef part. And I guess there's a reason for that. When you declare a structure in C like that, that's already a type definition. That is now a type. In C, I don't think that is a type. You would have to indicate struct, my struct. Yes, something like that. So in order to not have to retype this over and over again, they use a typedef keyword. In C++, one of the advantages is that you don't have to do that. Okay, but that's just a detail. It's not important. Functions, obviously. Return values, arguments, printing, printf, that sort of thing. You can learn all these things quite quickly too, if you don't know them. What else? As far as things like pointers or arrays, a lot of people get confused with these things. Sometimes there's confusion. If you have any confusion with these ideas, like if you're not sure what the difference is between an array and a pointer, and you know a little bit about it, but you're unsure, I would recommend that you just forget what you already know. It's just purge that information from your brain because it's of no use to you. Ununderstood information is of negative value to you. You're starting out with a wrong or broken understanding of something, and that's not a good place. That's not a good starting point. So you're better off just not knowing it at all. Just forget it, and it'll come up, and then when it does come up, hopefully it'll make sense this time around. What else? And really, there's not that much more that we need to know. All of the things that we'll talk about are going to come up, going to even much more complex kinds of data structures and operations and functions and various things. But it'll be in a natural way. Everything should follow one thing from the next. So you don't need to start out at the end, like Bucky here, who I keep ragging on, is sort of, in a sense, starting off at the end. In here, this code.
What is going on, everybody? My name is Bucky Roberts, and welcome to your very first C.
I just want to show you a little piece of code that's going to pop up in just a second. And it will be the last time you will see that code on this channel. I will not type that style of code in. I never have, in fact, in my whole life. What am I on? Am I on 1 or 2? I'm on 1. I'm on 2. Press 2. Going back on 1 again.
What is going on, everybody? My name is Bucky.
Okay. There we go.
What is going on?
There. Yes. Okay. I never use IOStream, and nor should you. So you can forget about that one, and you can forget about this. Okay. If you can write this program in C++, using what you already know about C, so that we don't need that in this particular case, and we don't need it in general. So goodbye IOStream, and just don't waste your time with IOStream. I can't tell you how many people I've run into who've spent endless hours trying to figure out what's going on with this IOStream. And it's just problem after problem after problem. Because IOStream, at least this implementation that exists, is, for me, an example of using C++ where it's not warranted. We have a tool to do this. It's called puts. Okay? You don't need fancy arrows and things. But the trouble is, once you start using the fancy arrows, they start winding up in other things, and suddenly you got the arrows going here and there and everywhere else, and then something doesn't work. And then there's no way to track down the problem. Because something just doesn't fit with the arrows for some reason or another. Whereas if you just use simple old puts all the time, or string copy instead of this sort of thing, then you won't have any problem. Don't use a tool, particularly one you don't understand, when you've already got a perfectly good understanding and working tool that does exactly the same thing. Okay, now I'm just wasting time, really. So I guess I'll stop here. And if I think of anything else, I'll fit it in somewhere else. Okay. Now, the next two videos would describe a little bit about setting up the system. There are limitations. It's assumed that you have access, at least, even if you're not running Windows, that you have access to a particular component that comes with Windows. And without that particular component, I don't know. I don't have a solution for that problem, unfortunately. Our history journey does have a restriction. After we're in the C++ part, then it doesn't matter anymore. For the beginning section, which is the most important part, you're going to have to be able to somehow get into one of these boxes. And I don't know how to do it on Linux. I know that a Mac you can do it. On a modern Mac you can do it. If you can't, you can't. You can still watch the videos. Some of them are quite interesting, even if you can't play around and do the things yourself. Anyway, we'll try and see if this is better than the other one. Alright, see you, and please have a look at the first few videos. I'm sorry about the audio quality, it's not that great. I'm going to try and fix it. I'm sorry, I speak too slowly. I'm slow with my words, always trying to get the proper wording out without using words that I know would be unfamiliar to you. So there's a lot of pausing and umming and awing, and I'd like to probably re-record a lot of that away. But as it stands, that's how it is now. Okay. Well, see you.